Okay, we're on. I can now start. Well, welcome everyone, and thanks for joining me this lunchtime. Hopefully you can hear everything, which means you can eat. And I've put the special filter on my webcam so you don't get all the crags and horribleness of me on a wet Monday lunchtime in Nottingham. This is a talk based upon a talk I gave just over a year ago called Skin Dose Management Technologies and Approaches. And I'm going to bring it up to date with what I've learned from the market and also some informatics initiatives that are ongoing at the moment. So let's, oh dear. Here we go. Finally, we have it. So what I'm going to talk about, because we've got quite a bit of time, I'm going to start with some context. Think about the current assessment methods, and some of these have moved on a bit since I last talked on this subject. Talk about the trigger levels and incident levels, and end up with some emerging technologies and thoughts about the future. But before I earn my keep, and to give me a chance to have a quick slurp of tea because I'm gasping, what I'd like is for you all to fill out the poll that should now be on your screen, and let's actually see what audience we've got. Oh, here it comes. So majority nerdy physicists and a few radiographers, one or two radiologists, cardiologists, or others, we'll never know, and a couple of people non-clinical with general interest. Can't even remember what I meant by that now when I set the poll up. Okay, so that's given us a broad idea, mainly physics staff, but hopefully this will be accessible for everybody. And it still won't let me use my keyboard, which is a pain. Okay. So, in terms of the clinical context, just recently I've heard clinicians saying, what's the problem? We don't get any skin doses, any skin effects, or any tissue effects. And that's often because they're not looking. And we've all seen, everyone puts this image up, we've seen it loads of times. And a lot of people would have you believe it's old news. And actually, if we can implement technology well, it may well be. But we still get this sort of thing happening in the UK. And this is quite a nice burn on the back of a reasonably large gentleman. This was a middle of the night primary PCI. And it's not totally surprising that this happened. So we're going to assume, for the purposes of this webinar, that it's a live issue. Starting at the turn of the century, which makes us all feel very, very old, we had ICRP 85, which was all about the avoidance of radiation injuries from interventional procedures. And the sorts of things back then, because this is now 15 years ago, so it's quite a way away, people were talking about patients being counseled on the potential risks, which is informed consent, and keeping records of exposure. And in those days, what was being recommended was for all procedures where you could get a dose more than 3 gray, and if you got more than one, keep it where it's likely to be repeated, so if the patient might come back. And they were also asking 15 years ago for the location and extent of the areas irradiated. And actually, that can be problematic unless you've got some tools to let you know what you gave where. And that's really where we're going to major on towards the end of this talk. Also, if you went over these levels, you needed to tell the patient what they needed to do about it. So there's an element of counselling, looking for signs, symptoms, and what they needed to do. It went on to say that we follow up the over 3 grays with the following regime, and it was quite prescriptive really. Review around about two weeks post-exposure, and if you see something, send them off to a dermatologist. I don't know about you, but most dermatologists I know absolutely freak at the thought of this happening, that their clinic's getting any busier. Also, we're going to tell the patient's GP, It's a very UK sort of thing to do, with something appropriate in relation to the estimated dose. I'm not 100% sure what that meant, but that was what we were being advised to do 15 years ago. And of course, if we're going to make this distinction between repeated exposures and non-repeated, then we need to identify people who are coming back, especially if they've been back within the last, say, 6 months. And then what we need to do is consider the information that we logged on them from that previous procedure. So there's an element of summation in the short term if people are having either repeated or staged procedures. Now this has been updated, coming much more up to date. 2013 ICRP 120, Radiological Protection in Cardiology. That still went on about consent. Consent is a good thing, like motherhood and apple pie. Now we're talking about storing patient dose reports. So our technology is advanced and we're still identifying repeat patients, which I think is a good thing. So we need to understand when people arrive, have they been here before? And then it talked about a slightly more nuanced follow-up set of trigger levels. We've still got the 3 gray actually to the skin, but now we're saying, well, we might not actually be measuring that. So what are we going to do? And we've got a trigger level for cardiology. This was an ICRP document 2 years ago. 5 gray at the IEC reference point, and I'll come back to that later on. I've got a slide that gives all the diagrams for that. Or a DAP level, a dose area product level of about 500 gray centimeters squared. We've still got the 2 weeks follow-up with a further one at 30 days. And actually, it does suggest that maybe you could do this by phone. Makes life a lot easier than everyone coming back to your practice. We've also, in the meantime, had some US guidance, quite a thick tome, heavily influenced by the likes of Don Miller at the FDA and Steve Walter at Columbia University. This was more general radiation dose management. It wasn't just cardiology. This was the whole gamut of interventional, what they call FGIs, fluoroscopically guided interventional procedures. That had similar triggers to ICRP 120. It added a fluoro trigger of 1 hour. I think if you're only doing fluoro, I'm not sure these days you'll get much in 1 hour, but it's a trigger. It gave lots of summarized data, which I'm going to show in a bit, and it had some nice patient management follow-up advice. So this is quite a good tome, and I'd recommend this to all of you to get. If we just get some context now about the frequency and complexity of examinations. I haven't got access to all the recent data, but an assumption that things are going up roughly 10% per year for interventional radiology isn't far wide of the mark. The RCR's just put out a call for more radiologists, a policy document where they quote figures like this. So about 10% per year. In interventional cardiology, we had the massive increase with the National Service Frameworks. That actually led to a 3-fold increase in PCIs in the decade that I've shown, sort of late 90s, early, what do we say, noughties? Not very naughty though. In terms of complexity, we're definitely seeing more complex interventions, but they're not necessarily the highest dose interventions. So I'm thinking specifically of TAVIs. Mitral clips will be coming along mainstream for a lot of us. I know in London they're already doing some of this. So we've seen more complex things coming along, but we're also seeing the existing stuff getting more complex in itself. So probably on average, certainly in Nottingham, we're seeing more stents per patient as we try and do more and more complex opening up of arteries. That definitely leads to an increased dose. In terms of the European picture, this was published a few years ago. This is the dark blues is the predicted and the light blue is the observed, or the observed as I've written. And the light blues show a little bit of a sign of tailing off. And I think in some European countries they might have hit the natural clinical limit. I'm not quite sure in the UK if we've quite got there yet for PCIs, but we're not far off. So we're looking at a broad increase over the last few years. We've also got some US pressures, and we're specifically talking about technologies this lunchtime. So the US pressures have been instrumental in changing some of the technologies available. Two states in particular come to my mind, California and Texas, have enacted regulations, and a lot of this was based around CT incidents, but it has an impact on interventional. Excuse me. They enacted state-based regulations where they wanted, in the patient report, quite precise and organ-based radiation dose information. And that led to a big push for the development of patient dose management software. We'll come back to this later. And also, I think if you look at the dicom scene, the working group 28, the physics group, are looking at patient-specific dose modeling. So a big change has come out of the state suddenly discovering doses and dose reduction. But it is nice that it has finally been invented. I don't know how many Americans we've got on the line today. So in terms of the context, let's just summarize where we are. We've still got some deniers, although hopefully I certainly encounter that less and less, and I think more people are educated to the issue now. Certainly at an international guidance level, we're seeing loads more stuff coming out. And just recently, there were two things came out of the States. There was NCRP Statement 11, which has come out about interventional and how to manage it, talking about quality assurance and peer review, and a big Environmental Protection Agency report, which came out, I think it was last week. It was actually highlighted in the AAPM newsletter. So try and get hold of that as well. I haven't actually read it myself. The NCRP one is worth reading, and it is a lot of common sense. In terms of practice changing, we're seeing increased numbers and complexity. So whatever our problems now, it's unlikely they're going to go away immediately. And the market and industry is starting to gear up for all of this. So we're starting to see some movement on the technology front. And that's what we're going to come to in a bit. So let's think about how we're assessing dose. Before I crack into this, I'm going to go around dose mapping, just have a quick chat about that, and then look at some of the limitations on the proxy metrics. But Sunny, can we have the first of the next two? So if you guys could, I'm going to do this as well. Let's see. This is interesting. So this is, do we have in-lab dose mapping tools? So are the clinicians real-time advised of skin doses? And actually, although we're going to be talking state-of-the-art, what I'm seeing from these live polls is that most people don't have it. Oh, the haves are catching the have-nots. Oh, and it's dropped back again. And then if we talk about the haves, out of those 10, there seems to be most are thinking it does add genuine value. I'm a haven't got, so I'm not going to click the bottom one. Okay, so what we're seeing is a picture where most people haven't got it, and those that have think it's a good thing. I think that's worth bearing in mind. So thanks, Sunny. I think let's end polls now and move on. So let's start with in-lab equipment-based mapping. We've got, at the moment, certainly in the installed base, a real mix. At the very basic level, some of the manufacturers now have got a very schematic average regional skin dose assessment. I'm thinking specifically of the Philips tool we've got in our Allura lab. It's basically got a picture of someone's back and it's divided into zones and it gives you a number in each. But the models are becoming increasingly sophisticated, as I've said, and I think actually there's a little bit of competition now amongst the companies to come out with really useful tools that will influence. Clearly they're able to model the skin dose. They know all the angulations, they know where the table position is, and they know what their tube and generator is up to. The only thing that limits what they can do is they don't know where the patient is yet, and I'm sure they're working on that. That's a picture of the GE one, which I find a very useful tool. Interestingly, I've had feedback from some clinicians who say they don't want that on the great big monitor in lab all the time because it actually distracts them and they start watching that rather than what they're doing. So if I was a patient, I would rather they watch what they were doing. This is the Toshiba, I think it's called the dose tracking system or something like that. I haven't actually seen this. I've seen it demoed. I haven't actually got it, or we don't have a lab that's got this in. The sorts of things it does, if I just go to this slide, if you run your mouse on your workstations over this picture, a little play button slide bar will play. If you click play, what you'll see is the gantry moving across, the values on the right changing as the views change, and the total, the maximum and the field of view peak skin dose values changing as well. So you can see this is a pretty good tool. In terms of other ways of doing it, well, actually, everything else is labor intensive, and I think moving forward, what we want is modeling in lab by the unit itself. We don't want to have to put things on patients. What I've got here is a picture of a film underneath a PTCA patient, someone who had a couple of stents put in, and you can see the hot spots on the film. You can develop it and you could work out the doses. It requires calibration. You can put a load of TLDs in a sort of cling film arrangement and plug that over the patient's back. But you've still got to read out the TLDs afterwards. And actually, it might be useful for research, but I really don't see this majoring in terms of real clinical practice. So I still feel that what we need to be looking at are these in-lab, good skin dose feedback, and we probably need clinicians to tell us what's useful for them, what actually will drive best practice. What we're also seeing now are dose management tools that take the information and produce a skin dose map retrospectively. Now, this sort of thing might be quite useful for people that come back, because one of the things that I think we're still lacking at, the models for in-lab mapping are getting much better, but the availability to store those maps in a sensible format and be able to bring them back and re-import them when a patient comes back is actually quite limited. And I think maybe this incidence map, this is actually courtesy of GE DoseWatch, just because that's what we happen to have, but there are other models on the market. This actually could be used to inform practice for a repeated or staged procedure, but I would prefer something longer term where I could import back into the lab. In terms of proxy metrics, clearly we've got our dose area product. This is quite old data now, nearly 10 years old, and I've over exit here. I've taken the worst set of data on this curve, but what I'm trying to show here is that if you've got a particular dose area product from a procedure, then we've got a dose area product here of just over 40 gray centimeter squared, but actually for all the patients we looked at in a sample of about 30 or 40 that make up this cohort, the skin dose could be anywhere between 250 milligray up to about 1.3 gray if you look at all the error bars on the calibrations and the actual numbers themselves. So not a massively great predictor of skin dose, although it's the best we've got in a lot of cases. The other proxy metric we've got is the reference air kerma, and here I've got a diagram that shows how this is, or where this could be measured. Most manufacturers on interventional equipment measure this 15 centimeters before the isocenter. The point being that if you've isocentered on something in the body, then very roughly 15 centimeters in front of that towards the tube is around about where the skin's going to be. And we know that for some PAs, that's out in the air, and for some laterals, that'll still be in the body. So it's not the best thing, but it's what we've got. Again, just like DAP, it accumulates over the whole procedure and doesn't take account of panning across the patient or different angulations, in which case it normally ends up being a pretty big overestimate. So let's think about our current triggers and actually what are our real dose levels that we're seeing out there in the real world. Well, the current triggers we've got are a DAP of 500 gray centimeter squared, cumulative reference air kerma of 5 gray, and a peak skin dose of 3 gray, and that's going to be inferred by those other proxy metrics. So this is for cardiology. The NCRP 168 document that I've already alluded to and spoken about, this is for all fluoro-guided interventions. And what did they do? They went with exactly the same values but added a 60-minute fluoro time. So these are our current triggers. I know that Colin Martin in Scotland did some work in neuro and thought that maybe these should be adjusted, so we could see the press starting, the peer-reviewed press giving us more procedure-specific follow-up trigger levels. But interestingly, the Society for Interventional Radiology in the US and CERSI in Europe have all signed up to these figures. So from a professional body point of view, this is mainstream now. This is what we're all working to. If we look at the literature, what are we actually likely to see? How many are we going to see? If we look at the NCRP 168, I said one of the good aspects of that was that it's got loads of cases, about 2,000, which is one of the biggest cohorts that I've seen recently. So the sorts of procedures where you might expect the top 5% to go over 3 gray are TIPS, biliary drainage, and renal work, renal angio or stenting. So in these types of procedures, you might expect a few of your patients to go over 3 gray. So you'd sort of just keep a wary eye, wouldn't you? 25% are going to go over 3 gray, and this is in the American summary data in 168. Uterine fibroid embolizations. We're now getting down to where you might expect 50% of your patients to go over 3 gray, and they were talk about neuro arteriovenal malformations and embolizations. And then actually, I think for the odd spine cancer, they were seeing almost 100% going over, but I think that was probably 1 out of 1. So for some of these examinations, what we're seeing is large percentages, but still small numbers. So when we think about how we're going to follow up, it's got to be appropriate, and we don't want to be creating a cottage industry around the odd patient. BIR did a sort of embryonic survey and gathered some data. And what we found, and this was over about 1,000 cases, was that what I've got here is the mean DAP and the median DAP for the procedures down the left. And really, those average levels are not causing us, they wouldn't cause me concern. But then when we look at what was the maximum DAPs from those that survey, again, there weren't that many cases that were going over the 500 trigger level. So we've got a coronary angio there, 700. EVARs are coming up, and actually what I'm seeing mostly is EVARs and FEVARs that are mostly going over rather than cardiology procedures. The other stuff wasn't coming anywhere close. So out of these 1,000 so far, if we look at the maximum skin dose indicator from that data, there was actually only 2 procedures that went, 2 procedure types that went over 1 gray. That was coronary and where's the other one? Iliac artery stenting. Although we have seen, I didn't have any skin dose indicator or the cumulative. It's the 15 centimeters in front of the isocenter. I didn't have any data for that for the EVARs, so we might have seen some there. Interestingly, though, even though we weren't seeing any single case large data, large values, what we did see was that already in that 1,000 data set, the same patient was appearing more than once. So it could be that our biggest focus needs to be on repeated procedures. So let's just summarize the triggers and doses. What we're seeing is the odd one going over. Small absolute numbers, but you still need to react robustly to those that go over. So with that in mind, now let's, Sunny, can I have the final poll? I would just be interested to know for you guys out there, what's the biggest DAP in units of Gray centimetre squared you've ever seen from a single procedure. Here they come, building up. Okay, not too many people frying tonight. So what we're seeing is about half of us from the 500 to 1000. So we're definitely seeing trigger levels with some significantly higher than that. Okay, let's call that a day, I think. It gives us a broad picture. Interestingly, one person said they haven't seen anything over 100. You're either very lucky or you need to check the units, or else you're not into interventional. So let's think about clinical follow-up. Interestingly, I think there's a consensus now around the interventional service itself has clinical responsibility for the follow-up. I don't see dermatology being massively involved unless you've got a real problem that you can't solve. The advice that's coming out is for repeat procedures, we probably should be summing in some way the patient doses for 6 to 12 months with a follow-up for about 6 months for those who are well over, just to check that we're not missing necrosis later on. In terms of how we sum patient doses for repeated, Steve Balter published a paper in Radiology. I can't remember the date, I think it was 2010, and there's an appendix in that that actually has the formulae at the back, a suggested formula for following up based on skin repair and radiobiological models. And the Americans like their equations, so go for it. The easiest thing is to just add them up. And this advice is actually based upon both what's written in the Balter and the NCRP report, and that's based upon a clinical skin repair of about 2 months, plus they've added in a safety margin. So if you go with the 2 months and build your own safety margin, you can amend those times above the 6 to 12 month repeats and the follow-up for 6. And really the crux of this is knowing that it's happened, that you want to follow up and give the patient some information before they leave. And what a lot of people are doing is they're just giving a small leaflet that says what you got to look for and who to ring up if you've got any concerns. And certainly in the UK, I think if you guys, anyone out there has got questions about UK practice, get in touch with the South Manchester crew. Elaine Holt is a cardiac radiographer and Lorna Sweetman is one of the physicists supporting them. They've got a really slick radiographer-led service up there. They do look at a lot of people who've got nothing wrong with them, but in terms of enabling radiographic follow-up and radiographers being in charge of the service, I think that's an interesting model. So get in touch with them if you've got more questions about what the UK is doing. Now, in terms of emerging technologies, I'm going to come at this from 2 directions: informatics, information, and the technologies themselves, the software and hardware. So starting with the informatics, life has actually changed a little bit very recently. IEC is the standards body that sets the standards internationally for the X-ray equipment we're talking about, and they published a technical standard last year. It's shown here, IEC 61910-1. They've all got horrible numbers, and this was called radiation dose documentation. And what it was an IEC interpretation really of a dicom structured dose report. And the reason for doing it was to have something that the interventional equipment standard could refer to, saying this is the way that manufacturers should be pumping out the information. Because although dicom is something you can conform to, it's not an equipment standard as such. So this was a way of trying to mandate what was going on in the manufacturing sphere. This was actually built into some guidance that the Department of Health published under Ian Chell's guise back into, I think it was 2014. One of the people online today, Ed McDonough, he was involved in that, and I was as well. And we were trying to alert people that you should be buying as many of these tools and building in these standards as possible. The problem is, when this was developed, it was agreed that this standard would be developed consistently and in synchronicity with the dicom radiation dose report. But actually, dicom's gone off a tangent, and this standard now actually is no longer fit for purpose because it actually referred to very specific dicom tags associated with bits of information that we thought was very important that the community needed so that it could work out what was happening to the patients in terms of dose. And these are, well, I'll move on to that. What it really was saying was there were two levels of conformance with this standard. A basic standard, which was your summary dose, the sorts of things with a bit of extras that you might find in a modality performed procedure step in dicom. But it was the total DAP, the total reference dose, the number of frames, the fluoroscopy time, etc. Quite useful overarching metrics from a fluoroscopy and radiography perspective. But in interventional, where we might want real-time feedback about what's going on the patient's skin, we wanted something a bit more than that. So we had the extended mode or conformance, which was really detailed. What's the tube doing? What's the generator doing? What are the coordinates of the gantry in the table for every single time you put your foot on the pedal? So this was an event by event radiation dose log. And actually, the standard mandated streaming so that this information was pumped out to analyzers so that you can have a real-time dose map. And that is one way of approaching it. Obviously, the equipment manufacturers in lab don't need to use this because they've got access to this equipment without necessarily going down the dicom radiation dose structured report route. What it didn't do, this standard, was mandate the equipment to follow it. And it's still, none of us know where the patient is. So it was still hampered by those two things. So the next thing we needed to do was amend the interventional equipment standard. And I've put the title up there for you, particular requirements for the basic safety and essential performance of X-ray equipment for interventional procedures. And manufacturers are going to, if they want to sell their kit, they've got to comply with it. And they're very serious about this. And if you want to comply with the interventional one, you need kit, but it's about the intended use. So any equipment used for interventional, even if it's a mobile C-arm, should really be complying with this standard. This standard was published back in 2000 and it's kept up to date with, sorry about that, I thought I'd unplug that. Kept up to date by a maintenance team, and it's mainly manufacturers, but there are two clinical people, Don Miller from the US and myself, and I would recommend other people getting involved in this because at the moment it's very, very manufacturer dominated and we need to get the user view across. And it's being amended. And one of the reasons it's being amended is to take account of that radiation dose standard. What's been agreed, and this is out for consultation with all national committees at the moment, is that we'll handle the review as two separate amendments. So the first one will be a quickie, which will hopefully come out within 2 years, assuming that all the countries agree to this. There will be some editorial changes. We will include the data set from the dose standard, the technical dose recording standard, but not mandate streaming, because some manufacturers felt that for mobile C-arm, this was OTT. However, to get around that from a user perspective, we definitely wanted skin dose mapping. So the manufacturers agreed that we could mandate that they had to skin dose map. We just didn't mandate how they had to do it. So this is really important stuff to get into the standard. And there was some other stuff in there about how fast you can recover your machine when it fails, putting a 10-minute limit actually for recovering it once you've got some power or something's gone wrong is actually an improvement on what's in there at the moment, and improvement to tableside controls so you can feel them when you've got dim lighting and clarification on water ingress. We don't like a lot of blood and guts coming into the interventional table. And then a more considered amendment 2 to this standard. And remember, these are the standards that are setting out what the kit has to do. Now, one of the things that's been happening in the States since they discovered dose and dose reduction is their equivalent of AXREM, the trade association, NEMA, has been getting together with the regulators in the form of the FDA and the professional bodies in the form of the American College of Radiology and the American Association of Physicists in Medicine. And they've been coming up with their own standards that sort of trump the international approach of IEC. And there is, a lot of you might have heard about some of the CT stuff that's coming out. Well, there's some interventional stuff around. And the current one is XR27. It's actually gone through a single amendment, and it's got lots of useful stuff for us nerdy physicists about having a physics mode for testing, be able to enter calibration factors. And we wanted this stuff to be built into the IEC standard, but the manufacturers are saying, well, it's not essential performance. This is for general best practice. So they're trying to fight this. So either this will have to be published as a technical standard, or else we've got to somehow fight the good fight and get this built into Amendment 2 for the actual equipment standards. But I think a lot of the things in there are very, very useful to the future use of information. So that's my informatics stuff. In terms of IC, finally, in terms of dicom, we've already seen how the radiation dose structured report is being amended, and actually there's a working group 28, and it would be great if IPEM could get someone on this. And this is looking at dicom structures to enable patient-specific dose. They're really pushing ahead with this for the CT side, but there is also work happening for the interventional. You might argue about how useful that'll be, but the dicom view is that if it's possible and someone might need it, there's a few people might need it, then we need vehicles to carry the information to enable it. And I think that's really where dicom is going with this. So all of this stuff is actually happening now as we speak. The next meeting of the IEC committee is in June, and there's a couple of telecons before then, and there is a current consultation out that all the professional bodies are at liberty to respond to, and I hope they do. In terms of image processing, imaging advances, now we're seeing two things. One that I'm not going to talk about today, which is just general things like 3D road mapping. So these are technologies that allow procedures to be planned so that you don't need so much radiation in the first place. It's not like technologies to reduce the dose rate. What we're saying here is a clever tool that says, well, actually, I don't need to have radiation on. And I did actually hear at a presentation last week that in somewhere in Europe, apart from the first 3D spin, they've actually done an EP ablation by importing a CT scan of a patient. So that was the 3D map of the heart, and then just using very, very low dose fluoro to map around and almost eliminating the need for radiation. And I would love to see that. The sorts of technology I'm going to talk about, though, is very quickly the image processing improvements that are leading to lower dose rates. So you do the same thing, but you get less dose for it, which is really enabled by the massive increase in processing power, thanks to all those teenage kids out there that want to play on games and all those parents who have got the purchasing power to buy them for them. This means we have a great gaming industry that's really pushing forward parallel processing and image processing. So what we see from that is increased noise reduction, because we can identify the signal better and then massively reduce the noise, but not the signal. We've also got elements of scatter identification and elimination. So what we see from that is lower detector dose rates, and in some cases, not necessarily yet in interventional radiology, the elimination of scatter grids, which then also lowers the patient dose for the same detector dose. So these are the thrusts. What we're seeing is headline figures, I think actually we've probably moved on a bit from here. And I'm referring here to stuff that Philips is talking about, their clarity. So this is 50% of their standard. It's not 50% of the lowest. I accept all that stuff. But we're looking at the image processing itself having the ability to reduce doses by about 50% in cardiac, by about 85% in neuro and more stationary objects. The amount of dose reduction here is limited by the amount of movement you have in your image. So what we're seeing is we can identify the signal, pull it out, and then absolutely kill the noise and then put the signal back, and real-time pixel shifting. And here's a picture of not such a beautiful neuro and then a beautiful neuro. But I'm sure all the manufacturers now are developing their own image processing pipelines. So in terms of further improvements, I think they'll all be doing clarity. They're all sort of doing clarity anyway in their own ways, just not calling it a specific thing like that. And maybe the grid-free scatter reduction algorithms could be applied to dynamic imaging. So we might get a gain from that. In terms of this technology, what we have discovered is that it meant at certain low dose fluoros and higher frame rates that actually we didn't have enough X-rays in the pulse and the electronic noise was starting to dominate the signal. So what do you do about that? You need detectors that have lower electronic noise. So Canon have got one of those, and a couple of the companies have bought into this. So what we're seeing, although it's currently offered by Siemens, I wouldn't go that so far with Philips. I would say they know about it. I think they've bought into it, but certainly they're not willing to offer it, certainly not in the UK. I haven't heard of yet. If anyone knows any differently, please chat to me or email me. But essentially we're going from an amorphous silicon detector to a crystalline silicon detector. We've got a lower electronic noise, which means in terms of the quantum signal, we can reduce the dose rate because we don't need quite such a high quantum noise to dominate the electronic noise. And that's really what we're seeing. So a slightly lower detector dose. I haven't seen any of these yet. Siemens have got it on there. I think their Artis QZen, but I haven't managed to have a visit to somewhere that's got that yet. So in terms of clinical pictures, these are some pictures from Siemens. What we've got on the left is a standard, presumably a Trixel, and on the right we've got the Canon detector, and this is 20 nanogray. Then we go down to 5, and then we go really low. How low can you go? This is when you start to see the benefit. So you need to go to very low doses to see the benefit of this crystalline silicon detector. In terms of tube developments, I'm going to roll through this quite quickly because we're running out of time. We've got flat emitters coming out now, Siemens, from Siemens, which is put on the, I think the Artis Q. That's where you get the better tube. So you can get higher tube currents at a smaller focal spot and a square focal spot profile. So you get the same limiting resolution in both directions. This has the following types of effect. This is a simulation. You can have less noise for the same dose at the same sharpness. So we've used a smaller focal spot. The sharpness is increased, which gives better image quality. So we can smooth it down and it looks the same as before, but with less noise. Or we can have less dose with the equivalent visibility. This is another simulation. So we started with a large focal spot and everyone thought it was fine. We now go to a small focal spot, so we get a better image quality, so we can reduce the dose a bit. The noise goes up, but we can smooth it back to where we were. So essentially, we're getting a dose saving, but similar image quality. And this is a real picture with 60% less dose, looking at a stent. So you can play around with these tools and you can either keep the same image quality, less dose, same dose, more image quality, that sort of thing, or anything in between. So there is potential here with improved tubes to reduce dose. What's the point of reducing dose? It's to skin spare. So from our perspective today, that's what we're talking about. And this is just some pictures of sharp and unsharp stents in two directions with a square focal spot as opposed to a rectangular. So in terms of a summary, we need to manage patient skin dose. I don't think anyone's going to say that's not true. We're seeing more numbers, more complexity. We're not 100% sure what the newer procedures will lead in terms of dose effects, but if it's more complex current procedures, that's going to be leading to an increase in dose. And the technology actually should be reducing the number of effects. And certainly we're getting better skin dose assessment where we might see an effect. So what are we looking at in the future? Well, my short-term summary of the future is something like this. In-room 3D models of real-time skin dose, and I think that's a X-ray equipment issue. Quantitative stored dose maps for repeat procedures, and wouldn't it be great when we pull them back that they could auto-register with the previous patient position. Real-time alerts, so we all know to go running after the patient, say, come back, I've got a leaflet for you. Patient-specific skin dose, that's an interesting one. I'm not 100% sold on that yet, but I've got an open mind. And summary dose data sent to a national registry using the IHE REM profile. And I know the PHE are just about to kick off a professional body project to look at how we might collect patient doses in the future. And let's hope we have a little bit of interventional in there to get better data for all of us. Or what's an alternative future? Well, maybe with all these technologies, we don't have any more deterministic effects. So my poor colleague that I often liaise with in the interventional lab doesn't need a eye projection anymore, and the population of Nottingham doesn't get a radiation haircut anymore. So I think we're just about coming to the end of the webinar. And I think if you type away, I can see questions, and we've got about 10 minutes or so. So I'm happy to answer questions from anybody. Oh, here we go. They're going to pile in now. Nice thing about this is I can ignore the ones I haven't got a clue about. Everyone's typing. This must be the typing equivalent of everyone talking at the same time. But the good thing is I can't hear you. Okay. In terms of how feasible is it to take the grid off for standard size patients, I was at a set of presentations from manufacturers late last week, and they were asked this question, and they don't think it's going to run, and they really see this being more use to peds and peripherals. In terms of air gap, I know they trialed this at the Brompton, and it looked a great thing to do, but then they rode away from it. So if there's anyone out there from the Brompton who can say why you didn't follow through with the air gap technique, obviously you've got the problem of magnification with an air gap technique, but it is a scatter reduction technique. And maybe the SIDs just aren't big enough to have really good consistent effects. I just don't know. I know it has been trialed, Cliff. Okay, I got a question from Matt. Useful to know how physics might be able to test against any new requirements. Potential new IPEM standards. Well, anyone from IPEM out there? I'd say if we want a new IPEM standard, they should have already started about 20 years ago. Things seem to take quite a long time coming out of IPEM. However, what I would say is if we can get the NEMA standard XR27 implemented on equipment, be it through the IEC route or not, that'll give physics ways of testing equipment because it'll give you a physics mode and also it gives you the images before they've been processed. So they're for presentation images. So I think that's really good. Will these slides be available, or can you email the presentation? No, I'm not going to email the presentation to 130 people who registered, but the actual presentation is available on the BIR website for free for anyone that wants to go back and have a look at it. Okay, then we've got Jonathan's been working on an open source extension to OpenRem that maps skin doses, so that's brilliant. It would be good though, I think, if longer term we were given all these tools and that people like Jonathan and Ed, who do a hell of a lot of work with all this stuff, actually it fed into much better products, because we haven't all got the resources to do the really good stuff that they're doing. That's just a personal perspective. And also I'm a Luddite and I can't program for my life. Anything else coming through? I don't know. Can someone just say, can you all see each other's questions? Because if you can, then Jonathan's put a link to Bitbucket.org, J.A. Cole, OpenSkin, where you can get your skin dose mapping software. Oh, you can. Thank you. And a prize for Ed, because he was quickest saying you could. I think we've still got about 5 minutes, so I'm happy to hang on till then. In terms of clinical follow-up, I think the best people to advise us on what do you do if you actually get effects. Clearly some are going to be very, very serious. We're talking about really high, greater than 10 gray necrosis type effects. They're probably going to need plastic surgery. In terms of I've got a little bit of reddening, then radiotherapy departments give patients skin cream, steroidal cream, a bit of moisturizer, that helps. If you've got something in between that and necrosis, then maybe we do need dermatological advice. Being non-clinical, it's difficult for me to be prescriptive about that. But the people you might like to contact, and I've had a question to repeat the contact names. This is at the Wythenshawe, so it's the South Manchester crew. Elaine Holt, H-O-L-T, is the radiographer who's really, really on top of it up there, doing really good work. And the physicist that supports her from the Christie is Lorna Sweetman, S-W-E-E-T-M-A-N. And they'll love me for giving their names out so that you can all pester them to hell. In terms of accessing documents from the USA, the ones that I've mentioned today, and I think someone said, can we have the references? What I will do is I will get a list together and get that uploaded so that it's with the talk in some way. The ones I've mentioned are XR27, which is a NEMA standard. If you Google NEMA MITA, M-I-T-A, XR27, it'll take you there. If you haven't been on their website before, you might need to register your name. Other than that, no problem at all. You can get it for free. The NCRP 168, and they've also just published 172, which is achievable doses, which is quite interesting. I'm afraid you have to buy, and the cheapest way is to buy a single copy electronically, but then you've got all the copyright issues. The NCRP statement number 11, that's really useful. Best clinical interventional practice. Again, just Google it. It's freely downloadable. Trying to think what other USA documents. I don't think there were any others. So hopefully, John, that answers your question. Someone's asking me what's my opinion on using, for example, thyroid protectors on a mammography. I'm not quite sure what you mean by that, but I don't think it's not really my field, so I'm going to dodge that one. No one can get at me. I'm safely in my office. Is it possible to get full presentation images off the Philips Allura system? I haven't managed to. The XR27 will make that possible, and I have asked them what their roadmap is to implement that. And I don't know, I haven't done it, and I'm not a Siemens or GE expert, so I can't answer for them. But if anyone's out there that could quickly type in the next minute or two, then go for it. Yeah, I think to answer Ed, it'll get you both. XR27 is about the ones before they've been processed and the ones that then go for presentation. So I'm probably getting muddled with my nomenclature, so sorry about that if I'm confusing people. Ruby's question is a lovely one. I'll answer that and probably have to make it my last one. I do think we need a national database for high skin dose effects and follow-up. I think that would be immensely useful. Whether we can run it on the back of the PHE initiative, I don't know. Failing that, I think there's a job for the professional bodies, probably led by the British Society for Interventional Radiology, to get cracking and sort something out, because it's something they do well in radiotherapy, and it's something we don't do quite so well in interventional radiology. And interestingly, at the presentations I was at last week, I had it thrown at me that, oh, and these effects are increasing, so we need to buy this, that, and the other options. Well, I said to them, well, how do you know they're increasing? And actually, they didn't really. And it's the issue of there might be the same incidents, but we might have better reporting. And in the UK, we haven't even got better reporting. So I think we just don't know how many are out there. In terms of a busy cath lab, if you mean cardiac cath lab, in terms of a tertiary referral centre, when we were higher doses, we thought that something like somewhere between, and it wasn't, the error bars are quite big on this, but let's say somewhere around about a quarter of our procedures might have been up around the 3 Gray level. But hopefully we're going to be better at managing patient dose so that as the complexity goes up, the incidence doesn't go up with it. So that's my estimate in a tertiary referral. If you're doing lots of angios, then you shouldn't be seeing any. And actually also don't go for the EP is very, very high dose line. It shouldn't be. And you shouldn't really get too many effects, deterministic effects, tissue reactions from EP in cardiac. Now, I think my time is running out. So I'm looking for a sign from Sunny, who's my controller back at base. Are we going to turn the recording off now, Sunny, and end this? That was code for please can we stop this now?